Okay, we're going to go through these 12 problems again that was on the quiz. We'll go through nice and slowly. Make sure you understand how to integrate using U substitution. This is the first problem, the integral of sine of x cosine squared of x dx. I said this was a power rule to make it look more power-like. I'll put the cosine of x, raise it to the second power, that's my n, and off to the side, the sine of x dx is supposed to be our du. So we've got a u, we've got an n, hopefully we have a du. U is the cosine of x, the derivative of that is negative sine of x dx, and obviously we're missing a negative sign, so I'll put a minus 1 in here, balance it with a minus 1 here, and then I can use my power rule. The minus sign here, the integral of u to the n du is the u over again, cosine of x, raise the power up by 1, divide by the new power, plus a constant. You could write this as minus cosine cubed of x. You cannot write it as this. Some people wrote this, which is just wrong. You're not cubing the x. So if you did that, that would be wrong. Okay. Parentheses, if you put it on the outside, if you want to do the trig, and put it in here, that's okay. You could do that as long as you add your constant. Okay, problem number 2. Number 2 was our trig function. The integral of sine of 3x. I had 3x in parentheses. Don't really need it. It would be fine without the parentheses. Remember how the trig rule goes. The integral of sine of an ugly, as long as you have the d ugly, works out to be negative the cosine of the ugly plus a constant. In this case, the u is 3x. The du is 3dx. I don't have 3dx. I only got 1. So the idea is sine of 3x. We can multiply by 3 to get our 3dx as long as we balance that with a 1/3. So here's the answer, 1/3. The integral of the sine is a negative cosine, and the ugly stays the same, 3x. Probably best to go ahead and rewrite this, pulling the negative sign out front, as negative 1/3 the cosine of 3x, and then add your constant. Okay, trig rule. Number 3 was our log rule. We have an x, we have an x squared minus 1, and a dx. The log rule, integral of 1 over u du, integrates as the natural log of the absolute value of u plus your constant. Okay, so to make this look more log-like, there's the 1, there's the x squared minus 1. I'll move the x dx over here, still multiplied, of course, but here it's explicitly in the numerator, here it's off to the side. The u is x squared minus 1. The derivative of that is 2x dx. I'm missing a factor of 2. Put it in, balance it with the 1/2, and there's the answer, 1/2. The integral of 1 over u du is the natural log of the absolute value of u plus your constant. Need the absolute values. Parentheses would be wrong. Okay, number 4 was our exponential. I have e to the 1 over x. There is an x squared dx here. I'm going to rewrite this to make it look more exponential as e to the ugly. And then off to the side, I have this 1 over x squared in the denominator, right? It's still multiplied. I can put it all over one denominator like this or separate it out. So the u is 1 over x. The derivative of that, using my reciprocal rule, is negative 1 over x squared dx. I'm missing a factor of negative 1, so put a negative 1 in here, balance it with a negative 1 out front, and then I can write my answer. The negative from here, here's the e, here's the u, here's the du, so e to the 1 over x, plus a constant. Okay? 5 was a power rule. We have an e to the x, but on the bottom I have a square root of 1 plus e to the x. This sort of keys me in as the power rule. I see a power of a negative 1/2 down here. So to rewrite it to make it look more power-like, 1 plus e to the x to the negative 1/2 power, square root of the denominator, e to the x dx. So the u is 1 plus e to the x. The derivative of that is e to the x dx. All the pieces are there. Just apply the power rule. You don't have to multiply by anything. It's just going to be the u, add 1 to the power, divide by the new power. I could divide by a half. I'll just multiply by 2 instead. Dividing by a half and multiplying by 2 are equivalent. It looks a little bit neater that way. Okay, number 6 was another power rule problem. We had a dx, we have an x, we have a log x to the 7th. And so the first thing, again, very similar to the previous problem, I'll write this as log x to the negative 7. The 7 was down in the denominator. That's a negative 7 exponent. I still have hanging around a 1 over x and a dx. So the u is the log, and the derivative of that is 1 over x dx. All the pieces are there. Don't have to do anything. Simply add 1 to the power, divide by the new power. Here's the answer. Log of x to the negative 6 divided by negative 6. Okay, plus a constant. It's important that you're squaring the u. I had a number of people write this, which is not raising the log x to the negative 6 power. That's taking the x to the negative 6 power. So this would be wrong. And don't do that. Make sure you include the parentheses around the function. Don't forget to add the constant. Okay, number 6 was our exponential. There's a sign here. There's an e to the cosine. Again, e to a variable power with a dx. So to make it look more exponential, e to the cosine of x, sine of x, dx. Hopefully that's going to be my du. Not quite. U is the cosine of x. The derivative of that is a negative sine of x dx. I'm missing a negative sign, so put that in as a negative 1. Balance it with a negative 1. I have e to the u with the du. Here's the answer. Negative e to the cosine of x plus your constant. Okay, number 8 was the variation. Remember the quiz or the previous problem was just x to the 2/3. I made it sort of a u substitution by putting 3x plus 7 to the 2/3 dx. The u is 3x plus 7. The du is going to be 3 dx. I'm missing the 3. Put it in, balance it. U to the n du. Here's the answer. The 1/3 was required. The integral of u to the n du is u to the 1 higher power. Add 1 to 2/3. I get 5/3. Divide by 5/3 or multiply by 3/5. Same thing. 3's conveniently cancel. So I get 3x plus 7 to the 5/3 over 5 plus a constant. You don't have to do the reciprocal thing. If you just had 1/3, 3x plus 7 to the 5/3 divided by 5/3, that's correct. This is a lot neater, just simplifying. Okay, the next one was the log function. So some people said this was trig. There is no trig rule that says the antiderivative tangent. We got antiderivatives of sines and cosines, secant squares, secant tans, but no antiderivative of tan. So you have to think of this as the derivative or the antiderivative of sine of x over the cosine of x. And then you can more clearly see the log appearing, 1 over the cosine of x, sine of x. Just moving the sine of x over. I'm thinking log rule, so 1 over ugly. This is supposed to be my d ugly. Ugly